Hello everyone. Here are all parts of number 5 off of page 118 worked out, explained, as well as the point values that you would get for each part. All right, so we're given this container drawn off to the side here. It has a shape of an open right circular cone. The height of the container is 10 centimeters and the diameter of the opening is 10 centimeters. So right now we know we're going to need radius, so we could just draw this in. So the radius would be 5 centimeters then. Water in the container is evaporating so that its depth h is changing at a constant rate. So because it's leaving, it's going down. So we get a negative 3/10 centimeters per hour. The volume of the cone is given to us. So for part A, we want to find the volume V of water in the container when h is equal to 5 and indicate units of measure. So first what we have to do, we'll start with the formula for volume. But notice h is just given to us. So over here, because with just about every single problem we've seen like this, we do have to set up a proportion. So we're going to say h is to 10 as the r is to 5. So we're going to solve this for r in terms of h. So we could cross multiply. 5h is going to equal 10r. So divide by 10, so we'll get 5h over 10, or h over 2. And we'll go ahead and substitute this in. So we get 1/3 pi times h over 2 squared times h. And we'll simplify this, so we'll get 1/3 pi times h cubed over 4. So we'll say pi h cubed over 12. So that is part A. Oh, now we have to evaluate still. So when h is 5, the volume is just going to become 125 pi over 12 cubic units. All right, so you get 1 point for finding this. Now throughout either the first part here or in part B, you also get 1 point for replacing the r with the h over 2. So technically we'll say right now, because we did this step over here, we'll say that that's 2 points. All right, now for part B, find the rate of change of the volume of water in the container with respect to time when h is 5. Again, indicate units of measure. So this is just a related rates part. So let's go ahead and write that out. So we want to find dV over dt. So the picture's already drawn for us. This is what we have to find when h is 5. And then we know that dH over dt is this negative 3/10 centimeters per hour. So the volume we came up with, we're going to go back to before we substituted in the 5, because that was only the question for part A. We came up with that pi h cubed over 12. So we know that dV over dt is going to equal 3 pi h squared over 12 times dH over dt. And we can simplify this to pi h squared over 4 times dH over dt. And then we'll substitute. So we'll say dV over dt is going to become, that'll give us 25 when h is 5. So we'll get 25 pi over 4. And then dH over dt was negative 3/10. We could simplify. 5 goes into 25 5 times, into 10 twice. So we're getting negative 15 pi over 8. This is volume, so we'll have cubic centimeters per hour. So we would get 4 points for this problem. And even though we did this in part A, they're still giving you a point for writing this simplified. So this could either happen. So technically, part 1 could be worth up to 3 points. So because we did this in part A, we would have gotten 3 points for that. If not, we could put that extra point here. 2 points for finding dV over dt, and 1 point for the answer. right, and then question C, show that the rate of change of the volume of water in the container due to evaporation is directly proportional to the exposed surface area of the water. And then what is the constant of proportionality? So we haven't really done one quite like this yet, but the context clues here, we have done them back in chapter 4, slightly. If you guys remember, like that steel beam, we had a proportionality problem with that. So let's go ahead and take a look at part C. All right, so to set this problem up, when it says show that the rate of change of volume, so that's dV over dt, is going to equal, if something is directly proportional, if one quantity is directly proportional to another, we bring in a value of k, where k is a constant, and then times the surface area, which we'll just write as area for right now. So we need to show this. So if we go back to dV over dt, that simplified form was that pi h squared over 4 times dH over dt. So that's going back to part B before we evaluated. So we're looking at this pi h squared over 4 times -3/10. So that's what I'm going to first write out. So dV over dt is equal to pi h squared over 4 times dH over dt, which is pi h squared over 4 times -3/10. So this was just before we were evaluating when h is equal to 5. So that was just specific for part B. So then we can get -3 pi h squared over 40. And we want to show that this is equal to k times some area. So when we're looking at the surface area of the water, so in our tank, we've got this part right here. And all of this is water down here. But the surface area is just the top part. So looking at the circular base. So surface area of water is just looking at that circular base. So that's just pi r squared. So now we want to show that -3 pi h squared over 40 is equal to k times pi r squared. Well, earlier in part A, we replaced r with h over 2. So we're going to do the same thing here. So we're going to get -3 pi h squared over 40 is equal to k times pi times h over 2 squared. So we get -3 pi h squared over 40 is equal to, I'll show it this way, pi times h squared over 4 times k. So now we could just multiply both sides by 4 times pi over h squared. I don't know if I said that wrong. 4 over pi h squared. So guess what? Pi h squares are gone. 4 goes into 40 10 times. Over here, these are gone. So we're looking at k is equal to -3/10. So our constant of proportionality is right here. And I kind of showed this backwards. But what you want to show is that if we go back up here, is we would be able to factor out a pi r squared and then show that that's area. But this process is going to be good enough that we're showing, and we could work backwards. If we found that constant of proportionality first, then we would be able to substitute it back in here and show that dV over dt is going to equal -3/10 times the area. So we get 2 points for this part, but then they give you at the very end 1 point for all of the correct units of measure. So there's getting that total of 9. So please let me know if you have any questions on this. I understand part C was a little different, but you would still get the majority of the points. Even if you didn't do part C, as long as you're labeling correctly, you could get a total of 6, maybe 7 points out of the 9 here, which is very good to achieve for. All right, so again, let me know if you have any questions.